In this lecture we're going to look at intrusion detection systems. So the main things we'll look at are threats, the types of intrusion detection system, network or host-based, agent-based systems, using SNART, analysing a few rules, looking at some intrusions, and then on to user profiling, honeypots, intrusion and intrusion prevention systems. Okay, so what are some of the key concepts that we have related to security and especially in defending against intruders? Well, one of the key concepts is called defense in depth. With this we use several different lines of defense, each with different types of defense. In this way it becomes increasingly difficult for somebody to penetrate each of the layers of defense. In this case we might use some low-level defense as first-level defense, as we'll see that could typically be a firewall. Then we have second-level defense, which is a bit heavier, third-level defense, and then on to the heavyweight defense, which is fourth-line defense. It does no good to give the same type of defense for each system, as somebody could easily overcome each of the levels. Another key concept that we have is that we want to simplify things, and we typically define that things on our side or within a side of our organization are trusted. Things that are outside are untrusted. Obviously we need some place for there to be access from outside to our inside systems, so we typically define a demilitarized zone where untrusted and trusted traffic can exist in the same place. Okay, so what is it we're trying to protect? Well, obviously we need to protect our assets from outside damage. We also need to defend or protect our systems, our servers, email, web, and so on. A key component these days is also that we need to defend and protect our data. It could be databases or messages. And we also need to protect our users from outside abuse. And unfortunately, even the best defences can be breached. Okay, so what we have is that we would typically put several lines of defense in the way. And as we want to be able to detect an intrusion before it actually gets to some sort of profit, we can insert intrusion detection systems within each of the levels of defense. And then someone trying to break a line of defense can be detected before they get to a profit stage, which is where they would damage systems, assets, users, or data. So let's look at what the threats are. The threats can be many, and if we look at defining a single gateway or firewall from the system, then we can draw a boundary around our organization and define that as the organizational perimeter. Typically most organizations have just a few of these gateways, as it can become difficult to protect against external threats if there are more than one gateway. We obviously have data stealing influences from outside, external hacks, denial of service attacks, personal abuse, worms and viruses, fraud, and terrorism. Along with this, we need to guarantee some sort of access from inside to outside, such as corporate access, email access, and web access, and so on. Unfortunately, it was found that most of the breaches will typically come from inside an organizational network. So in this case, it doesn't solve the whole problem by focusing on the main firewall or gateway, as the problems could already be inside our own network. So internal threats are as big a problem as external threats. So defense in depth typically involves us setting up firewalls, demilitarized zones, having servers with inside public-facing servers with inside the DMZ. We can have network address translation devices to hide the internal infrastructure of the network. We can have localized firewalls, switches, and then we can set up intrusion detection systems around the network in order to detect any intrusions. So our key objective is to make sure that users can communicate externally and work effectively, but that intruders cannot do damage. Okay, so what are the different types of intrusion detection system that we can have? Basically, the main type that we have is misuse detection, and that typically uses standard signatures which have been well proven and developed, and this type of system is good for detecting worms and viruses, a scripting attack, and also for attacks such as denial of service. For other types of attack, typically ones that are more human based, we have what's called anomaly detection, and that focuses on defining what is normal and then monitoring activity to see if it deviates away from this normal. So areas such as personal abuse, fraud, an external hack from a human, and data stealing will typically be focused on anomaly detection. So the systems we will look at are typically focusing on misuse detection, but anomaly detection is a growing area. Along with this, we can have what are called system integrity verifiers, and with these watch key system files and will keep a hash signature of them, and then if any of these are changed in some way, then an alert is triggered. A good example of this is tripwire. Other areas that are monitored include the Windows registry and any root administrator level privileges. Log file monitor is another intrusion detection system, and with that the system processes the logs which are gained on servers and hosts, looking for patterns of change. Swatch is a good example of this type of system. And we also have network intrusion systems which typically monitor data packets on the network. A key thing is that if possible we want to stop any intrusion which leads to a profit. So an intrusion detection system will try and detect each of the phases of an intrusion, and typical phases include outside reconnaissance. That might be someone gaining DNS or IP information on the network. They then might look at an inside reconnaissance, looking at the address layout and where network devices are, and then onto an exploit, which might be cracking a password, breaching a firewall, and so on, and then into a foothold stage where they might go up the levels of privilege until they get to an administrator level, and then possibly on to profit. As much as possible, the intrusion detection system should try to detect these things in an early stage so that it can be detected and hopefully overcome. A key principle in intrusion detection systems is whether it is host-based or network-based. A host-based system will typically reside on a computer and listen to the traffic on a single machine. So host-based intrusion detection systems listen for ingoing and outgoing traffic only for that one host. A network-based system listens to all the traffic within a certain network, within a certain subnetwork. So we can see here that we might use intrusion detection systems here for some sort of audit log purpose, an intrusion detection system here to listen to the traffic within inside the DMZ, and one here to listen to traffic within the inside network. Okay, so we've placed one there, and these are the network ones, and there is a host-based one for each of the servers and also for each of the hosts. In placing a network-based one, it is not possible in a standard switch to listen to all the ports of a switch, but it is possible with a hub. Unfortunately, with a switch, the bandwidth is increased with each of the ports which is monitored. So many intrusion detection systems suffer when they listen to many ports. On a Cisco switch, it's possible to listen to one or more of the ports by setting up a span port. In this case, we set up a VLAN. VLAN 2 is for port 2 and port 3 and port 4, and then we can define that we monitor a VLAN, or we can monitor specific ports. So the traffic which is going to and from each of these ports and to the VLAN will also go to port 1 in this case. So we can move the IDS around, and in this case the IDS can detect attacks against a specific host and against a specific server. This one here could listen to attacks from outside, and this one can listen to attacks which were successfully breached the firewall. This one here can listen to internal attacks. Intrusion detection systems themselves are typically what are called agent-based. And with agent-based, we can split the objectives of the security system up into a number of hardware or software-based agents. So in this case, we might have an IDS agent. As we'll see, a SNART agent is one. We might also have a quality service agent, which is monitoring for things like bandwidth, latency, and so on. And this itself is configured by some sort of management agent. And then there is an auditing agent, which is monitoring what is actually happening on a system. We might also have a reconfiguration agent, which will reconfigure any devices in the face of a threat. So an example of this might be that the security agent itself might have some requirements defined for it. It can then be up to the security agent to write some rules, in this case for the SNART IDS. So this is the rules that are actually written for it. In this case, it detects when a user on FTP tries to change to the root folder. Then, once the rule is written for the SNART agent, the security agent can then invoke SNART, and it will run and create alerts which can then be viewed by the security agent. The advantage with this system is that we can create multiple instances of the SNART agent and have one security agent which basically just has to monitor the logs. When a security alert happens, it might be possible for the security agent to send a device reconfiguration message to the reconfig agent. The intrusion detection system itself must capture data packets, and one of the most popular methods for Windows is using the WinPCAP library. WinPCAP is a port of the Linux libpcap library and has been ported on to Windows. It typically uses a capture filter, which is a string to define the data packets that are to be captured. So in this case it might be IP or ICMP, or it could be from a specific host or from a specific TCP port. Typical applications which build on WinPCAP include Wireshark, SNART, and also user-defined agents. It is also possible to define our own agents by building on WinPCAP. WinPCAP itself is built on C++, so it is possible to use a .NET wrapper to make it easier to use. This allows us to get an API interface. Then we can define our own string to define what's actually captured. This shows a simple example of how we can show our network connections. In this case, it gets each of the network connections that we have and displays its name, the mode, the IP address, and whether it's a loopback address or not. So if we take a look at a simple example, so in this case our program is here. This gets all the network connections that we have. An important element is that the wrapper for WinPCAP has been added, and that makes it much easier for us to actually develop our code because it has the intelligence sense in it. Okay, so we can build our project. Oops. Build. And then we can start to debug, and hopefully this will allow us to show that we have 3 network adapters. The first one is the Gigabit Ethernet, the second one is the wireless adapter, and the third one is a Microsoft Tunnel driver. If we now go back to our presentation, WinPCAP also allows us to define an event routine. In this case, whenever a data packet arrives, it will call up this event. In this case, we basically just show the time and the length of the data packet. So we should be able to see that we can actually view our data packets as they come in. So again, if we go to our examples, which should be available from the website. For the second one, we now have our data arrival, packet arrival event, so we can build it and start to run it. And we can see here, even though we're not actually accessing any websites, we're still getting some network activity. And we can see here these larger packets, 1314, tend to be the larger ones with data packets in them. Okay, so this .NET code wrapper gives us a good interface to the WinPCAP library. One of the most popular intrusion detection systems is SNART, and this section will look at some of the configuration of it. SNART basically reads in a rules file, and it can either be standard signature or it could relate to anomalies, and it will produce event data whenever an alert fires. Whenever a rule fires, it will generate an event, and it can also be used to log data. So a simple rule that we might have typically starts with alert, log, ignore the packet, and so on. In most of the cases we'll be looking at, it will generate an alert into the event data file. We then see the protocol, and the protocol can be TCP, IP, ICMP. After this we have the source IP address and the source port, and a destination IP address and port. So we can use the word any for any IP address and any for any port. Next we define the payload. So in this case we are defining a binary pattern, so it's defined in hexadecimal in this case, or we could define a text sequence. We can also look at different offsets, different distances, and so on. And then there is the message to display at the end. Along with this, we can have an SID number and a rev number, and there are well-known intrusions with revision numbers. For example, 336 revision 7 relates to an attempt to change the system administrator's account in FTP. So it's possible to define localized rules, and these are defined with SIDs over 1 million. So let's look at a simple SNART rule. So in this case, alert on TCP from anywhere to any destination, and the content is the word the, and the message will be the found. So when we run SNART, we define the -c option and define the rules file and then the log folder. Once it detects the word the, then we should be able to have our alert file, which will define when it was found and some of the payload. So if we take an example, so here we have SNART, and in the first case we have a simple rule with the word the, and we have simple batch file. So in this case it's interface number 3 that we're going to read from, and the log folder will be this one, and the -k defines that the log will be in ASCII format. So if we now run SNART, and then we should hopefully be able to pick up the word the. And then we quit SNART, and we can see here that it's picked up three alerts and is logged 3 times. So if we now go to this folder, and we can see that in alert.ids it has picked up the last 3 alerts that we actually had. So the key thing we can see here is the source address and the destination address, and then source port and the destination port. In this case is the web server. In our case it only detected outgoing words. So if we analyse what we've actually received, it shows us the data link layer, the Ethernet layer, So in this case, Ethernet looks like this: source address, destination address, type, and length. These are all defined. The hex 800 is an Ethernet frame. And you can see here the MAC address of the source, of the destination, and also of the source, and a timestamp. For the IP part, we can see the source IP address, the destination IP address, the time to live, in this case 128, and the IP length, which should be 20 bytes. Another key part is the protocol part, and the protocol in this case is TCP. TCP is going to be the next thing that comes along. Other protocols might be one is ICMP, EGP, IP6 over IP4, ESP, and AH, which are used in IPsec. For the next part, we can see the TCP part. The key elements of this are the flags, which are contained in here, the sequence number for the send and acknowledge, the window size, and TCP length. SNART can also log data packets, and it will log them in terms of the destination address, where a folder is set up for each of the destination hosts, and then an IDS file is set up for the source and destination port numbers, which should be fairly unique for every conversation. A key element in security is to analyze the flags, because the flag tells you the state of a connection, whether it started or has finished or is in the middle of a connection. The key flags for this are push, acknowledge, reset, SYN, and FIN. On the internet, and for all client-server communications, in fact virtually all communications, at the start of a connection we see the server is listening. So the server listens, and that's the main thing between a client and a server. When a client wants to connect to a server, it sends a SYN flag, it sends a TCP segment with the SYN flag set. If the recipient wants to make the connection, it sends back a SYN acknowledge, and then the client sends back an acknowledge flag. After this, the connection has been made and data can be sent. So it's these three flags: SYN, SYNAC, and then ACK is the standard sign of connection. So we can also test for each of these flags with inside SNART, in this case flags for SYN. We can look at it for different directions: to the server, to the client, from the client, and established, and so on. So in this case we can see a standard capture. So the first data packet that we see, the TCP segment shows, so this is the source address and it's going to a destination. We see SYN. The server then responds back to the client with a SYNAC, and then the server responds back to acknowledge this with an ACK. So the client sends back to the server the ACK, after which the connection is made. A key element is also the window size, which is negotiated, and that defines how many of these TCP segments can be sent before the other side has to wait for a reply. Another element that we have that is important for logging purposes is the ARPs. With ARP, a device which is looking for another device will typically send out an ARP to find out what the MAC address is of that destination IP address. So in this case, if this machine was looking for this one, it sends out an ARP to all the devices on the network, and the network itself is bounded by a router. So all the devices here, the ARP request for the IP address. So in this case it's saying who has that IP address, tell this node. So when it comes back, there is a reply, and the reply defines at which MAC address it is at. And the only device which receives that is the one that requested it. So next let's look at a few intrusions and how SNART can detect them. So a key element for an organization is to define a policy, and that involves looking at the aims and objectives of the organization, its legal, moral and social responsibilities, and also, importantly, its technical feasibility. The policy is then implemented, and it might be in terms of an operating system rights, domain rights, firewall rules, event log definition, application rights, and so on. There is then an evaluation of it, which can feed back into how well it actually meets the policy definition. Along with this, there might also be an audit process to make sure that the policy is working as the implementation is. So in the policy definition, there might be a definition of what's allowed and what isn't. So let's look at an example of a policy violation. So the policy violation is that MSN Messenger login is not allowed. So in this case, the basic signature is that MSN Messenger server uses a port of 1863. So in this case, we're detecting the flow to the server and whether it's established, and the user allows us to detect the content user inside the data packet. So in this case, this packet here will be the one that triggers an alert. Same again with our .NET agent. We can define the destination port. So in this case, we have our event routine. We can define our destination port and also whether the received data begins with user and then has TWN in it. In this case, we detect an attempt where an intruder tries to do a change directory to the administrator account. So we detect the destination port of port 21, and then we detect change W to tilde root on it. Here, with the .NET agent, we can detect port 21, change directory, and also a tilde root attempt. This is an example of what we see with an FTP connection. To test FTP, we can use Telnet on port 21. We can see the login, and then the user sends change working directory, and then is asked what their username is and their password, after which they are logged in. A help shows all the commands that are available, and one of them is change the working directory, cwd. So in this case, we can look at the present working directory, change the working directory to the top level, look at the present working directory, and we're at the top level, and then this causes the violation where we get change the working directory to tilde root, after which SNART and .NET will be able to detect the intrusion, the possible intrusion. Napster uses port 48, and in this case we have an extra little bit of content here that is detected. The .NET program again detects the same port and then a typical byte sequence. With QuickTime might be another policy violation. In this case we're detecting it on port 80, and we detect that there is a content user agent QuickTime. So this is what we typically see with a web access when it's running a QuickTime movie from a website, and in this case the system will detect the user agent QuickTime 7.1. Again, destination port 80, and then we detect the user agent here. This shows an example of it. There's some movie file, and we can see here there is a user agent actually defined QuickTime Win Internet. Another one, it could be a virus inside an email. The SMTP is a typical email relay which is used to send emails and runs off port 25. So in this case we detect that the content has file name equals with also the .exe, and that picks up that there is an exe file associated with the email. Again, destination port 25, and we detect exe. Another several strange ones are where we get a sin and a fin. The sin means start and the fin means end, so there's something rather strange about the sin and fin occurring together. So we can detect the sin and fin together. A Christmas scan typically sets all the flags. This type of attack can be used to overload a server with connections. The server has to cope, and all the intermediate devices cope with each of the data packets. It obviously uses up some CPU and some memory, and servers can become overburdened after a while if there are too many connections. So you can see here sin and a fin flag set. We might also see a Telnet root login. So in this case, login 3A is equivalent to a colon, login root. So this provides us with a possible policy violation. A typical threat that we have is with port scans, when an intruder can scan a server to find out which ports are actually open. To determine which ports are open on a certain machine, the netstat-a program can then list each of the ports. In this case 1035 is open, 3389, EP map and so on are listening ports. So an intruder could actually connect into one of these ports. Another method that an intruder might use is a ping sweep, where an intruder sweeps over all the hosts within a certain network and finds out which ones are alive or not. This is a typical type of surveillance of the network. And we might also see account scans, where an intruder, once they find a login server, might continually go through a username and try various passwords. So the problems that we might have are anonymous passwords, using the same password as a user ID, a password of course, user root logins, weak passwords, well-known passwords, and social engineering. So it's important that we when we're running SNART to make sure that it's and our own agent that it's actually working correctly. So one tool that we can use is NMap, and NMap allows us to be able to scan a host for the ports that are actually open. So in this case we're running SNART and we have a scan rule, and in SNART we can have a preprocessor, and in this case the preprocessor is FS port scan, which allows us to pick up a port sweep and also a ping sweep. So in this case it will log to the port scan.log. Then once it's running, we can run NMap on a destination node towards that single node. It should be noted that NMap should not be used against any other machine apart from ones under your ownership. So in this case it goes to the machine and it finds out that there are 2 ports that are actually opening. When we look at the log, we can see here that it's picked up the scan, and it tells where the scan actually came from. You can see here the port range was from port 80 to port 2869. This was a scan just for one port, and this was a scan for a range of ports. SNART is useful for picking up standard signature based attacks, but there are some methods which are useful in detecting more human based attacks, such as in fraud detection. One method which has obviously some moral and social issues is user profiling. So one application of user profiling is where a bank might keep a profile for each of the users. So in this case we have Fiona, Fred, Emily and Michael, who have certain profiles for them. So the profile will define where their location is, their gender, what their typical purchases are, how many purchases they make a week, and so on. So then when a purchase is made by the user profiler then checks against the typical profile for that user, and then if they find that it matches, then it will be accepted. Unfortunately, we might get an intruder which might try to be the user, and it would be possibly picked up by the profiler because the purchase or the type of purchase would be different from the one they normally did. So in this case we can use this type of behaviour to detect fraud. A more localized one is where it could be used on a localized network, and this would only be used on a highly secure network. In this case we can profile the individual traits of the user, such as where they are in the organisation, how fast they type, what types of applications they use, when they work, and what types of equipment they use, and so on. Then when the user logs in, a profile is sent to the machine, and the machine listens to the user and tries to match up the typical profile with the user. At the end of a session, the profile is stored on the system so that when the user logs in again, the profile is more up to date. Then when somebody who isn't the user tries to log in, uses their username and password, then the agent should be able to detect it as, for example in this case, Fiona types at 54 words per minute and the intruder only types at 10 words per minute, so that it can pick up an anomaly. Another area which also has some social and moral consequences is honeypots. With a honeypot, an organisation might leave one or more machines open for an intruder. So with this, they might stop an intruder from going directly to a production machine, and will thus get stuck with the honeypot. So it might have default passwords on it, dummy users, lots of ports open, or it could react to a worm or a virus or some form of scripting and entice a system, a threat in. So with honeypots we can either have a high interaction honeypot, and that's where we actually have a machine which responds as a real machine does, or we can have what's called a low interaction honeypot, and this is where it simulates the various protocols. A good example of this is the HoneyD honeypot service. With HoneyD we can have a config file, and in this case we create multiple profiles. HoneyD can simulate many types of operating systems and devices. So in this case we want to simulate XP, and in this case the default action will be to reset all the connections apart from the ones we define here. So the ports that we've left open are 110, POP3 for email, port 80 for web, port 25 is blocked, port 21 is FTP, and port 22 is SSH. 139 is dropped. And we can also simulate a Cisco router so that the intruder might think they're logging into a router. So in this case it's a PIX firewall, and we leave open port 23. All the other ports will be dropped, and then what we can do is we can bind this router model to a certain IP address, so we can have multiple hosts on the network through the honeypot. So an example of the Perl script. So in this case, on the router, we have port 23. When port 23 is invoked by the intruder, it calls up a Perl script, which will then simulate a login to a Cisco device. We can see here the user gets 3 logins, and then it will prompt them for the username and password. So it's through this honeypot it is possible to detect when someone is trying to break into a system. We can also get what are called intrusion prevention systems. Along with this, we can have the concept of an inline and an out-of-line intrusion detection system. In this case, we can have a device, in this case it's a Cisco firewall, and the IDS can actually run in the device. So then it can either drop a packet which it thinks is malicious, cause an alarm, or actually reset the connection. You can also have an associated syslog server where alerts and logs are actually stored. SNART is an example of an out-of-line system where it listens passively to the data packets and then can actually generate alerts. So the advantage with an inline IDS is that they can act on an intrusion, but it also has a performance impact where it must process the packets. It's also difficult to upgrade any signatures for new threats. And out of line obviously can't react to these threats, but has the advantage that it's easier to craft IDS rules. So an example of a Cisco intrusion detection system is that Cisco have defined various signature numbers. For example, 2000 is an informational alert, and it's ICMP echo. 3040 is a null TCP packet, which is an attack. So this shows an example where we can log our IDS threats to a syslog server, and in this case we define that the action is to drop on info and reset a connection on an attack. And by default the signatures are actually running all the time, and if we want we can actually disable any of our threats. In this case we are disabling threat 1005, which is a spam signature. In conclusions, we've looked at various systems, especially our own agent-based system, and looked at SNART as a good example.